The main idea behind this particular set of notes is to make sure that you understand that the limits are the heights, the answer is the height, and the input that you plug in to get that height, the x value, is under the word LIM. So make sure this is the input and that the answer is the output. Always start by just drawing or imagining the curve. Always plug in the number first. Oh, look, 3 times 1 plus 2 is 5. And if you trace it at 1, you get a height of 5. And I would, for this set of problem sets, like you to indicate, preferably with not too gross a set of brackets. Here, let me make that prettier. It should look like the side of a cello. There we go, a little less bad. So the answer is 5. Okay, so make sure that you have the notation properly. The little plus sign means only work at it from the right. So this time when we trace, we don't find anything at 0 because you can't divide by 0. But if you look at the graph, it looks like this. But there can't be anything at 0. We put a little hole. The height, if you trace at 1, trace at 0.1, trace at 0.01, and the height stays at a constant height of 1. So if you're looking at it from just the plus side, this is a 1. I'll make a little note. If I want to come at it from the left side, that height would be -1. Whatever. Yeah, so if you don't have the plus or the minus sign, because it's approaching 2 different heights, one on each side, the limit doesn't exist. Okay, my favorite picture, I've already drawn this for all of you, but for those of you who are absent. If you graph this function, it looks like a line, and we will do the algebra eventually, but if you trace at 3, there's nothing there, so what height is this? Remind you that if it doesn't say left or right side limit, you should probably try it on both sides. And you get values like 5.99 and 6.01 and so forth. This limit is 6. Okay. Oh, did I say what? Yeah, I did. All right. Next one. This one's a fake you out because you have 0 on the top. Zero on the top is not a hole. 0 on the top is an x-intercept. Now, it flattens out a lot more than that, so it's hard to tell that it's the x-intercept at 4. But this is 0, is the height. So just remind yourself. Okay, so I really want to make sure people understand why we're doing this. So first of all, the limit is the height and I talked in class about why we're talking about limits is because to get a good approximation for an instantaneous rate of change, we need to take a look at what happens to things as the slope the slope between the 2 points approaches 0 over 0 if the 2 points are close together. So that's what the big goal is all about. But I know I'm not saying anything, but so x plus 3 times x minus 3 over x minus 3 is undefined at x equals 3. But if you have the weasel word limit in front, since the limit doesn't actually care what happens at the point, it only cares what happens nearby, you can cancel things that are just really close to 0. X is approaching 3, you get x plus 3 when you cancel, and that is just 6. And that's why this sort of stuff works. And we're going to spend a little bit more time on doing it algebraically, but right now I want to practice graphical versions. So if I graph sine x over x, if I graph sine x over x, it goes don't forget you're in radians. But I want to graph it, zoom in, because I only care about it really close by. So from -1 to 1, it's basically just doing this. Max height is at 1. There's a hole there. Interesting. So because you can't divide by 0. Okay, so we will use 0, 1 to start our slope, our average rate of change. What's a secant line? It is a line that crosses in two places. Doesn't try to just touch. Okay, so the slope of the secant line is going to be it's a negative slope. Looks good from the picture. We'll fill in the table, and this is undefined, but the limit is 1, whatever. I'm going to try and figure out what the slope at 0.5 is, halfway between. I wonder if it's just half of negative 0.159. Well, we'll find out, won't we? Or if it's approximately equal to negative 0.159. Because remember, the point itself that we care about is here, and it kind of looks like the slope ought to be approximately parallel. So let's just see. I've filled in some numbers. Notice when we get to here, I'm going to want to have a little bit of extra accuracy, because otherwise everything gets swamped in the round-off error. So I'm going to just put a little note that this is 2 extra digits here for this last calculation. Okay. The more accuracy you have, the less the round-off error swamps things if you're getting really close together. Notice it doesn't matter which one you put first, you just have to be consistent. So if I have 0.5 first on the bottom, I have its number first. And again, I didn't bother to put the 1s in except for the very last calculation. Look on the table if you can't read that. So you look at the numbers, and the closer they are together, the more accurate you're likely to be. So we'll be saying it's approximately negative 0.163. How do you actually calculate it? We will be learning how to calculate it with calculus eventually. Algebra, okay, factor and cancel. We have to distribute before we can factor and cancel. Notice it's the division by 0. It's that single h that I want to cancel. So let's see what we get when we multiply out. Also notice that 3 plus h, when you square it, FOIL properly, 9 plus 3h and 3h is 6h. Okay, so then what we have then is this. We'll be learning a variety of techniques, and the big thing is anything that doesn't have an h should end up canceling. Oh, look, the 18s are going to cancel. What you do depends on what kind of function you've got. Be careful, you can't cancel h from part of it, so. Okay, so in other words, the careful thing to do is to factor on the top. And then cancel. Factor, cancel, plug back in. Once you have canceled the division by zero problem, you can then feel free and safe to plug in to find the limit. There you go. Now if I graph I have to use extra parentheses around the top. And I have to use x instead of h. I just smushed that x, didn't I? Let me fix that. So if you graph the function, it'll look like this. You won't see the top unless you make the y. Okay, there you go.